On October 3, 2025, 7 moons of Mars were positioned to make the most significant observation of their lives. 3 Atlas was passing only 0.3 astronomical units away from Mars, close enough that every spacecraft in Mars orbit could image it at unprecedented resolution. NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, the UAE's Hope probe, China's Tianwen-1, and India's Mars Orbiter mission. All of them were focused on the same target. The cameras were ready and the spectrometers were calibrated. Everything seemed perfect. But the result was zero. No blurry photos, no raw data, and no signals. All the space agencies on Earth fell into silence. Within hours, the US government declared a funding crisis, and 15,000 NASA employees were put on unpaid leave. Other agencies used excuses like technical issues and data processing delays, and failed to share any information. The images that were expected to be released by October 5th never materialized. Spectroscopic data that could have revealed the composition of Atlas was either moved to secret servers or never shared at all. The real strangeness began here. The timing wasn't a coincidence. October 3rd wasn't just the date when Atlas made its closest approach to Mars, it was also the moment when the line of sight for all the satellites was at its most optimal, and the lighting conditions were the most favourable. This was the only opportunity to clearly see what this object truly was. Yet, instead, a global blackout occurred, with 7 different space agencies simultaneously falling silent. Now, we will analyse step by step the orbital mechanics behind this event, the imaging capabilities of each Mars spacecraft, and why these 7 independent agencies all went silent on the same day. We'll explore what these spacecraft might have captured, why the government's shutdown decision coincided exactly with this timing, and how institutions that usually compete for prestige manage to coordinate and suppress information simultaneously. Whether you believe this was a bureaucratic coincidence or a more deliberate plan, one undeniable truth remains. October 3rd was the day we should have learned the truth about Atlas. But on that day, we found out that all governments looking at Mars went silent at once. Let's begin. But before we dive into this deep analysis, don't forget to hit the like button, subscribe to the channel, and let us know in the comments where you're listening from. What time is it over there? Do you think the October 3 silence was a coincidence or a coordinated move? Share your thoughts. The Mars close pass had been predicted weeks in advance. Astronomers had calculated Atlas's path toward the Sun with millimetre-level precision. According to the calculations, the closest pass to Mars would happen on October 3, 2025, at 1437 UTC. At that moment, Atlas would pass at a distance of 45 million kilometres, or about 0.3 astronomical units. This was only about 30% of the distance between the Earth and the Sun. Although not extremely close by astronomical standards, it was more than suitable for high-resolution observation from spacecraft in the right position, and indeed Mars moons were in the right position. 7 separate spacecraft from 5 different space agencies were all pointed toward the same target in Mars orbit. This was not a pre-planned joint mission. Each agency had independently noticed this opportunity and made preparations with their own resources. After all, if an interstellar object is passing near your spacecraft, you must observe it. Such an opportunity may only come once in a lifetime. In 2017, we only obtained a few blurry images of Oumuamua, which passed through the solar system. In 2019, 2I Borisov provided clearer data, but it didn't pass close enough to resolve surface details. Atlas was different. It was passing much closer to Mars, and we had 7 spacecraft ready to observe it. NASA's Mars Reconnaissance Orbiter, MRO, was equipped with HiRISE, one of the most powerful cameras ever sent to another planet. This camera was capable of resolving details as small as 30 centimeters on the surface of Mars from an altitude of 300 kilometers. Although Atlas was 45 million kilometers away, HiRISE had the capacity to distinguish structures just a few kilometers in size. If there were unnatural geometric shapes, antenna-like structures, or regular patterns on Atlas's surface, HiRISE could have clearly seen them. A special observation window had been planned for October 3rd, and the spacecraft's guidance commands had been uploaded weeks in advance. ESA's Mars Express satellite was also on the task. This spacecraft, which has been in Mars orbit since 2003, was equipped with a high-resolution stereo camera and various spectrometers. Thanks to its observations from different angles, it could reveal three-dimensional structures. Observations from multiple satellites at the same time would enable the mapping of Atlas's shape, rotation speed, and surface characteristics. Such a comprehensive observation opportunity was almost unprecedented in space research. The UAE's HOPE probe, launched in 2020, was also part of the observation chain. Although its primary mission was to study Mars's atmosphere, it had cameras capable of imaging distant objects. Thanks to its elliptical orbit, it could observe Atlas from a wide angle. Moreover, its thermal spectrometer could measure the object's heat emissions, helping to determine whether it was an ordinary rock or a system producing internal energy. Machines produce heat. If Atlas was warm, it would have been a strong indication that its nature could be technological. China's Tianwen-1 mission had also been in Mars orbit since 2021. Its high-resolution cameras were capable of detecting large structures even from a distance. Moreover, China had recently adopted a more transparent policy in its space program. If Tianwen-1 had indeed imaged Atlas, these images should have already been shared. However, no data was received. This raises two possibilities. Either the observation was unsuccessful, which is highly unlikely, or the obtained data was intentionally hidden. India's Mars Orbiter mission, or Mangalyaan, had been active since 2014. Although it had more modest equipment compared to other spacecraft, it was capable of both imaging and spectroscopic observations. Furthermore, the Indian Space Research Organisation, ISRO, typically shared its data publicly. If they had observed Atlas and detected something unusual, this data would have been published within weeks. Yet there was no statement from them either. 7 spacecraft, 5 different agencies, 1 target, and the same day. This was the greatest opportunity to closely study an interstellar object ever captured by humanity. But nothing was shared. No press release, no raw images, no updates in data archives, only silence. The first sign came on October 4th. NASA's official site, which was regularly updated with news and images, was completely empty. Normally, the MRO team would share raw images within a few days, but this time, nothing had been uploaded. Social media accounts had also fallen silent. When science journalists began asking questions, NASA's press office issued a brief statement. Data processing delay, technical issues, no release schedule. Then, later in the same day, the US government declared a budget crisis. Congress had failed to approve the new budget for the fiscal year that ended on September 30th. The discussions had been ongoing for weeks, but no resolution was reached. With the funding approval delayed, non-essential agencies like NASA had to halt their operations. Around 15,000 employees were placed on unpaid leave. Only mandatory operations related to flight safety continued. Data analysis and sharing were completely suspended. The official statement called the timing unfortunate but inevitable. However, the real issue lay right here. This crisis had been known for weeks, but why was it announced exactly on October 4th, one day after the Atlas pass? Why not a week earlier or a week later? This timing either served as the perfect excuse for a deliberate cover-up, or it was truly a coincidence. And someone inside NASA simply decided, let's hold off on sharing for now. International agencies just like NASA also fell into silence. ESA made a brief statement on October 5th announcing a data transfer error. The UAE's HOPE probe team stated that their priority was Mars atmospheric observations, even though just a few weeks earlier they had announced they would be studying Atlas. No statements came from China. India merely said, "Data is being analysed. It will be shared at the appropriate time." So everyone presented different justifications, but the result was the same: silence. On their own, these explanations might seem reasonable, but when all of them are combined, the picture changes. Previously, each agency had announced the observation opportunity, generating public excitement. Yet when October 3rd arrived, they all went silent at the same time. This gave the impression of a coordinated effort rather than a coincidence. Harvard University astrophysicist Avi Loeb stated in an announcement on October 12th that such simultaneous data concealment had never been seen before in the history of space research. Normally, agencies would compete to share the initial data they obtained. However, in the case of Atlas, this competition had completely disappeared, replaced by quiet collaboration. According to Loeb, this could mean that the agencies encountered something unexpected and felt the need to coordinate among themselves before making it public. However, it would not be entirely accurate to speak of a full blackout. On that day, some amateur astronomers managed to image Atlas with ground-based telescopes, even if at low resolution. So, the event certainly took place. This also means that professional instruments hold much higher quality data, and this data is currently sitting on the servers of NASA, ESA, CNSL, ISRO and the UAE. Yet, even after 32 days, none of it has been released. To understand why the October 3 silence is so critical, it's important to know how advanced the systems of the 7 spacecraft in Mars orbit on that day were. These were not amateur telescopes or experimental probe models. Each of them was equipped with some of humanity's most sophisticated observational devices. They were designed to operate for decades, to analyze the atmospheres of planets, and to examine surface details with micron-level precision. And on October 3, 2025, all of these spacecraft were directly observing 3I Atlas, which had been the focus of mystery since its discovery. NASA's Mars Reconnaissance Orbiter, MRO, was the most powerful eye in this observation chain. It was equipped with the HiRISE, High-Resolution Imaging Science Experiment camera, a reflective telescope with a half-meter diameter primary mirror. It could capture images with 3 different color filters in visible light, and the resulting images were so clear they could be compared to photos taken from a plane flying at high altitudes above Earth. Under ideal conditions, HiRISE could distinguish objects as small as 30 centimeters from a height of 300 kilometers above the Martian surface. This means theoretically it could have seen a basketball sitting on the surface of Mars. So what would happen if we scaled this incredible precision to Atlas? For an object 45 million kilometers away, the resolution would drop to about 2 to 3 kilometers per pixel. This is still an impressive value. It would have allowed HiRISE to distinguish features on Atlas's surface the size of mountains, plateaus or massive structures. If Atlas is really an object 30 kilometers wide, a calculation based on its brightness and reflectivity, albedo, HiRISE could have resolved it at around 10 to 15 pixels in width. Of course, this resolution wouldn't have been sufficient to show fine surface details. However, it would have been more than enough to define the general shape of the object and to determine whether it was an irregular natural asteroid or a smooth geometric structure. In nature, such clear symmetry and regular patterns are rarely seen. That's why the moment HiRISE looked at Atlas, it was a unique opportunity not only scientifically, but also in terms of human history. The HiRISE camera doesn't just take single-frame photographs. While orbiting Mars, the MRO also captures stereo data by imaging the same target from different angles. This allows for the 3-dimensional structure of the observed object to be revealed. For Atlas, this technique would have enabled a precise understanding of its shape and structure. Was it thin and elongated like Oumuamua, spherical like a comet nucleus, or displaying an entirely different form? If there were antenna-like structures or panel-like protrusions extending from the surface of Atlas, stereo imaging could have clearly shown them. A special observation pass was planned for the MRO on October 3rd. The spacecraft was directed toward Atlas, and the data collection sequence was activated. Camera images were successfully captured and transmitted back to Earth by MRO. However, after these data reached NASA's servers, they disappeared. They were not made public, nor were they shared in any data archives. For the scientific community, this meant a significant silence. The European Space Agency's Mars Express spacecraft carried a different but complementary set of observations. Its high-resolution stereo camera, HRSC, was developed to map the surface of Mars in 3 dimensions. The HRSC did not offer the same high resolution as HiRISE, but it had a much wider field of view. This feature made it ideal for observing rapidly moving transient targets in the sky, such as an interstellar visitor like Atlas. The HiRISE camera doesn't just take single-frame photographs. While orbiting Mars, the MRO also captures stereo data by imaging the same target from different angles. This allows for the 3-dimensional structure of the observed object to be revealed. For Atlas, this technique would have enabled a precise understanding of its shape and structure. Was it thin and elongated like Oumuamua, spherical like a comet nucleus, or displaying an entirely different form? If there were antenna-like structures or panel-like protrusions extending from the surface of Atlas, stereo imaging could have clearly shown them. A special observation pass was planned for the MRO on October 3rd. The spacecraft was directed toward Atlas, and the data collection sequence was activated. Camera images were successfully captured and transmitted back to Earth by MRO. However, after these data reached NASA's servers, they disappeared. They were not made public, nor were they shared in any data archives. For the scientific community, this meant a significant silence. The European Space Agency's Mars Express spacecraft carried a different but complementary set of observations. Its high-resolution stereo camera, HRSC, was developed to map the surface of Mars in 3 dimensions. The HRSC did not offer the same high resolution as HiRISE, but it had a much wider field of view. This feature made it ideal for observing rapidly moving transient targets in the sky, such as an interstellar visitor like Atlas. The UAE's Hope Al-Amal satellite had a different advantage: its orbit. While other Mars missions typically orbit the planet in low or moderate elliptical orbits close to the planet, Hope moves in a high elliptical orbit, reaching up to 43,000 kilometers. This allows it to observe Mars and its surroundings from a wide-angle perspective, which is ideal for observing a passing object closely. On October 3rd, Hope was near the aphelion, the farthest point of its orbit. This position gave it the opportunity to observe Atlas from an angle that no other spacecraft had. Hope's Emirates Mars Infrared spectrometer, EMIRS, operates in the infrared wavelength range, measuring surface temperature and heat distribution. If Atlas's surface was emitting heat beyond just reflecting sunlight, meaning it had an energy source within, EMIRS could easily detect it. This is because in the universe, an object emitting heat generally indicates either an internal energy process or a surface covered with something other than ordinary rock or ice. Hope's position, its instruments, and the observation window on that date made it one of the key witnesses to this event. However, it too remained silent. Thermal imaging may be the most critical data in understanding Atlas's true nature. The surface temperatures of natural objects in space, such as comets, asteroids, and planetoid fragments, depend solely on how much sunlight they absorb and how well they can radiate that heat. During its Mars pass, Atlas was approximately 1.5 astronomical units from the Sun. At this distance, a dark, low reflectivity object would have an average surface temperature of 200 Kelvin, or about minus 73 degrees Celsius. A bright, icy object, however, absorbs less heat and would be around 150 Kelvin, or roughly minus 123 degrees Celsius. If the EMIRS instrument on Hope detected temperatures much higher than this, it would be impossible to explain with ordinary physical laws. Such a difference would indicate internal heat production, and inanimate rocks do not produce heat. Heat is the trace of energy transformation. Electronic systems, mechanical movements, propulsion systems, and even microscopic processes caused by friction leave thermal signatures. Therefore, a hot Atlas would mean that Atlas is not natural, but technological. The UAE's HOPE mission team announced at the end of September that they would observe Atlas during its pass. Emirati scientists highlighted the historical significance of the opportunity to study an interstellar visitor and emphasized that HOPE's infrared instruments were perfect for detecting potential thermal anomalies. However, October 3rd came and went. No data was shared. A brief statement released on October 7th stated that HOPE's primary mission was Mars atmospheric observations, and therefore it was not pointed at Atlas. This statement was in direct contradiction to their earlier announcements. Either the mission plan was changed at the last minute, which is extremely rare and would require justification, or observations were made and the results were intentionally concealed. At this point, China's Tianwen-1 mission comes into play, adding another layer to the mystery. Tianwen-1 was China's first independent mission to Mars, and after a 7-month journey, it entered Mars orbit in February 2021. The satellite carries a medium-resolution camera and a high-resolution camera. This second camera is powerful enough to see details on the Martian surface down to less than a meter. For an object like Atlas, 45 million kilometers away, the resolution would drop to about 5 to 10 kilometers per pixel, more than enough to determine the general shape and detect large surface structures or symmetrical lines. Tianwen-1 also carries a spectrometer capable of analyzing surface composition and a magnetometer to measure surrounding magnetic fields. These sensors play a critical role in distinguishing between natural and artificial objects. If a magnetic anomaly was detected while Atlas passed nearby, meaning an unexpected electromagnetic field formation was observed, this could have indicated that Atlas was not an ordinary asteroid. However, China remains silent. It is almost certain that Tianwen-1 made observations with such powerful equipment, yet the results have still not been shared. China's space program has undergone a remarkable transformation in recent years. Once a closed structure, the China National Space Administration, CNSA, is now becoming increasingly transparent, aiming to enhance its scientific credibility and international prestige. The Tianwen-1 mission is one of the most prominent examples of this shift. When the Zhurong rover successfully landed on Mars in May 2021, CNSA released both landing images and telemetry data to the public within just a few days. Even the rover's discovery of ancient water traces on the surface was published in peer-reviewed scientific journals, helping China gain a respected position in space research. This history clearly reveals the institution's attitude toward data sharing. CNSA understands how important public interest and international recognition are. Therefore, if Tianwen-1 had observed Atlas and determined it was just an ordinary comet or asteroid, the data would likely have been shared immediately. However, the absence of any statement raises a different possibility. Tianwen-1 may have observed something unexpected, and these findings could be being coordinated with other governments before being made public. India's Mars Orbiter mission, or Mangalyaan, is one of the most modest yet most impressive achievements in the history of Mars exploration. Launched in 2013 with a low budget, this spacecraft earned India the title of the first country to successfully enter Mars orbit on its first attempt, and it did so as the first nation in Asia to achieve this milestone. Although Mangalyaan was equipped with simpler instruments compared to NASA or ESA's massive flagship missions, its systems were highly functional. Its Mars color camera can capture surface images with a resolution of a few kilometers from an altitude of 500 kilometers. This camera could also image distant objects, such as an interstellar visitor like Atlas, albeit at low resolution. The mission's methane sensor is designed to detect trace gases in the atmosphere, but it can also be used to analyze light reflected from distant objects. This could have provided clues about Atlas's composition. Additionally, the spacecraft carries a thermal infrared imaging spectrometer, which serves a similar function to HOPE's EMIR system, but with slightly lower sensitivity to measure surface temperatures. As a result, Mangalyaan could have also collected valuable data on Atlas's heat emissions and energy balance. Considering these capabilities, India's failure to observe Atlas or release its data further strengthens the suspicion that the silence is not a coincidence, but rather a globally coordinated blackout. Mangalyaan was scheduled to observe Atlas on October 3, 2025. This was part of the mission's extended phase, and the Indian Space Research Organisation, ISRO, had clearly announced this at the end of September. ISRO had stated that this observation would mark a historic moment as the first time an Indian spacecraft would directly image an interstellar object. The country was filled with national pride. India, alongside NASA and ESA, would be part of humanity's interstellar exploration history. However, when the day came, instead of the expected announcement, there was silence. On October 6th, ISRO issued a brief statement announcing that the data was in the analysis phase and that the results would be shared after the review was completed. 29 days have passed since that statement. Normally, ISRO would release such preliminary data within a couple of weeks, especially when it involves observations with national prestige. This long delay suggests an internal debate within the organisation about the nature of the information to be disclosed or external pressure to hold back. This pattern is not exclusive to ISRO. The same situation is repeating across all 7 spacecraft. Each was equipped with the necessary instruments. Each was in the right position, each had planned to observe, and each went silent immediately after October 3rd. The agencies offered different excuses: technical issues, data transfer errors, budget crises, priority changes, but the outcome remained the same. No data was released. This situation is inconsistent with the normal workings of planetary science. Typically, when an interesting event is observed, institutions compete to be the first to make an announcement. In the scientific world, priority is extremely important. The team that announces first gains both scientific prestige and the right to be cited. Delaying publication means losing that opportunity to others. However, if all the institutions act simultaneously and in the same direction, it can only be explained by one justification: coordination. And such coordination is only possible if there is government-level agreement. Such coordinated delays are rarely seen in history. In 1991, when NASA's Galileo spacecraft passed by the asteroid Gaspra on its way to Jupiter, the images were released within a few days. Gaspra was an irregularly shaped rock, as expected, and there was nothing to hide. However, when the Hubble Space Telescope detected unusual movements in Neptune's atmosphere in 1994, the release of the data was delayed for weeks. This delay was not due to government pressure, but scientific caution. The researchers wanted to be sure the observations were accurate. In the Atlas case, however, the delay lasted much longer, over a month. This duration is far beyond standard scientific verification processes. This suggests that the delay was not due to technical or academic reasons, but rather political or strategic ones. There is another element that makes the October 3 blackout even stranger. Amateur astronomers were looking at the sky while the professionals remained silent, and they actually saw the transit. Several amateur observation groups from different parts of the world turned their small telescopes toward Mars and managed to capture Atlas's close pass. Of course, the images they obtained were low resolution. Atlas appeared only as a bright, slightly flickering dot. But this was still significant because it proved that the object was really there, moving along the predicted path. That same night, some professional astronomers also made observations with larger telescopes. Among them, several independent research groups shared their early data on online forums and amateur observation network sites. There were no dramatic anomalies in the visuals, but the resolution was very low. It was impossible to distinguish surface features, shape differences, or spectral details. Nevertheless, compared to the data collected by the 7 professional spacecraft in Mars orbit, these were only a small preview. Those spacecraft were equipped with high-resolution cameras like high-rise and infrared spectrometers. They had gathered information at a level of detail that amateurs could never reach, and that data still hasn't been shared. Harvard astrophysicist Avi Loeb specifically highlighted this point in an interview on October 12th. He said, "Even if the images were unclear, they should have been released. Even if they didn't provide conclusive evidence on whether Atlas was artificial or natural, such data is, by the nature of science, shared. Uncertainty is not something to be ashamed of in science. Observations are released, the community discusses, and different interpretations emerge. That's how progress happens." The key issue Loeb emphasized was this: institutions do not withhold data because of uncertainty. On the contrary, if they are unsure, they share it, because they need the community's input. But if nothing is shared, it shows they are actually certain, and what they are certain of is something they do not want to share with the public yet. From this perspective, the October 3rd silence may not just be a technical glitch or administrative delay, but rather a deliberate withholding of information. There is a detail, easily overlooked but actually at the very centre of everything. The October 3 observations were not only aimed at capturing images, the primary goal was spectroscopy, because cameras only show the shape of an object, while spectrometers reveal what it is made of, and composition determines the line between natural and artificial. Natural space objects, comets, asteroids, planetesimals, are formed entirely by cosmic and geological processes. Their basic components are silicate minerals, metal oxides, water and carbon dioxide ices, and various organic molecules. They consist of mixtures of elements found in nature. However, artificial objects do not carry this natural diversity. They are made from refined metals, alloys, and composites created with controlled proportions. This difference can be clearly seen in spectroscopy. Each material type absorbs or reflects specific wavelengths of light. If Atlas is an engineering product, absorption lines specific to materials like aluminum, titanium, or steel alloys would appear in its spectrum, lines that would never be seen so pure and dense in nature. On October 3rd, every spacecraft in Mars orbit had the equipment to make this measurement. The CRISM spectrometer on MRO, Mars Express's Omega, HOPE's EMIR's, Tianwen-1's multiband spectrometer, all of them gathered data in the visible, near-infrared, and thermal infrared ranges. These instruments could have analysed Atlas's surface composition, clearly showing whether it was an ordinary rock or an engineering product. But no explanation came from any of them. There was no simple confirmation like, typical comet ice is detected, nor a reassuring statement like spectrum matches known asteroids. No preliminary results, no summary report was published. Instead, a profound silence took hold, and this silence was not just due to a lack of data, but due to a spectrum that did not match expectations. After October 3rd, the agencies faced a choice. They could either release the data immediately and face potential public backlash, or they could conceal the results and create a shared narrative, coordinating their reactions. They chose the second option. This clearly tells us something. The October 3 observations were indeed ordinary. They were so extraordinary that they required an unprecedented level of coordination, going beyond normal scientific practices. The governments considered the risk of releasing these data to be more important than the potential benefits of transparency. And that's why October 3rd was not just the date of a transit. It was the day humanity looked up at the sky, stayed silent, saw something, but lacked the courage to speak about it. The US government shutdown, which began on October 4, 2025, was presented as the result of a political disagreement, but its timing was strikingly inopportune. Normally, such budget deadlocks are routine in Washington. Congress negotiates a temporary funding bill, known as a continuing resolution, every year to allow federal agencies to continue their operations after the fiscal year ends on September 30th. These negotiations are often tough, leading to brief symbolic shutdowns lasting a few days, which are quickly resolved. However, the shutdown in the fall of 2025 was not one of those. It lasted for 3 weeks, furloughed 15,000 NASA employees, and, coincidentally, coincided with the date when everyone was expecting the Mars Close Pass data. Let's closely examine the timeline. The last day of the fiscal year was September 30th. Congress had to approve a temporary budget law by midnight. Intense negotiations had been ongoing throughout September. Both the ruling and opposition sides were telling the public, "We don't expect a shutdown, a compromise is near." However, on the evening of September 30th, the talks suddenly stalled. Interestingly, the deadlock was caused by some spending items added to the budget later on, which had nothing to do with NASA or space research. As a result, no agreement was reached by midnight. Thus, all non-essential government activities were suspended. This definition included NASA. The agency began furloughing its employees on the morning of October 1st, exactly 2 days before the Atlas closed pass. According to many observers, this timing seemed far from a coincidence. Budget negotiations in scientific institutions like NASA are usually anticipated in advance, and critical mission periods are typically excluded from shutdowns. But this time, it was different. The federal shutdown occurred, like the closing of a curtain, at the most crucial moment of the scene. But it's important to remember this: NASA's mission operations are considered essential services, even during government shutdowns. Spacecraft cannot simply be abandoned. They must be monitored, their orbits maintained, and necessary commands sent. Telemetry data is received, communication is sustained, and systems are kept under surveillance. So, while the budget crisis began on October 1st, the Mars Reconnaissance Orbiter, MRO, did not halt its mission. The Atlas observation on October 3rd went ahead as planned. Data was collected and sent to Earth. NASA's Deep Space Network antennas received these signals. What was paused was not the mission, but the flow of data, the stage at which science meets the public. Engineers processing images, scientists analysing data, communication teams preparing press releases, all were on furlough. Normally, raw data and images would be released within a few days, but this time they were held in NASA's servers. The infrastructure for public data transfer was effectively shut down. This situation, even if inadvertently, created a perfect excuse. When journalists asked NASA, "Where are the images of the Atlas closed pass?" the response was simple: "Due to the government shutdown, our data processing and sharing processes have been halted." Technically, this was correct. Employees were indeed on leave, and systems were suspended. But this explanation also served as a perfect smokescreen. Because if the October 3 data showed something extraordinary, for example, a structure difficult to explain naturally, a heat trace, or a geometric anomaly, NASA could easily remain silent during this period. No one could demand transparency. Everyone was focused on the political shutdown. The 3-week shutdown ended on October 24th. During this time, NASA's public communication virtually ceased. Social media accounts fell silent, press releases were not issued, and online gallery updates stopped. When employees returned, the priority was to clear the operational backlog from the 3-week hiatus, not to bring up an already forgotten Mars pass. By the end of October, the news cycle had already shifted. The Atlas pass was now old news, and NASA still had not released those images. The October 3rd silence, therefore, seemed to be relegated to the dusty shelves of history, both for technical and political reasons. But this silence was actually very well timed, and perhaps that's precisely why it remains unexplained. Now, let's look at the international institutions. They didn't have the government shutdown excuse like in the US ESA. The European Space Agency has an independent structure, unaffected by the short-term political crises of its member states. Its budget is approved annually and is not influenced by federal deadlocks. The UAE Space Agency works with its own state funds. It is not subject to the US budget disputes. China's space program is directly controlled by the central government. Situations like leave or staff cuts cannot occur there. India's ISRO operates with long-term, stable funding. Therefore, none of them could hide behind the shutdown excuse. Yet all of them delayed publishing the October 3rd data. They provided different justifications, but the outcome remained the same: silence. On October 5th, ESA announced that Mars Express had experienced a data transfer error during its observation of Atlas. According to the statement, the spacecraft had successfully recorded images and spectral data, but the data became corrupted during transmission to Earth. A retransmission was planned, but it was stated that this would take some time. Technically, this is possible. Data corruption happens occasionally. Mars Express, launched in 2003, is now an aging spacecraft. Periodic issues with communication systems are normal. However, what stands out here is the timing. Mars Express sends data several times a week, and corruption cases are rare. For this to occur during such an important globally watched observation is statistically unusual. Moreover, ESA had announced that the data would be retransmitted. So why, after 32 days, has it still not been sent? If the corruption truly happened, the retransmission should have been done within days. This delay seems to suggest a political or strategic pause rather than a technical glitch. Was the corruption truly random, or was it part of a blackout mechanism? The stance of the UAE Space Agency was even more contradictory. On October 4th, Emirati scientists wrote on social media that the HOPE probe had successfully observed Atlas, and the data was being analysed. The posts were filled with excitement, clearly implying that something interesting was captured. However, 3 days later, on October 7th, the official statement reversed everything. The agency stated that HOPE's priority that day was Mars atmospheric observations, and no targeting had been made towards Atlas. This statement directly contradicted the previous posts. Shortly afterward, the social media posts were quietly deleted. When journalists requested clarification, agency spokespeople did not respond. This silence was particularly noticeable as the HOPE mission was built around public engagement and transparency. The project was designed to raise scientific awareness in the Arab world and share data openly. Therefore, hiding data was directly against the mission's philosophy. So, even in countries without a government shutdown, the same pattern repeated. First, expectation and excitement, then sudden silence. Statements contradicted each other, posts were deleted, and data disappeared. And the world still hasn't learned what an interstellar object passing by Mars on the night of October 3rd really looked like. China's approach was distinctly different from the others, because they said nothing. The China National Space Administration, CNSA, made no announcement about Tianwen-1's observation of Atlas on October 3rd. There was no mention of data collection, analysis, or the close pass itself. The event was ignored as if it had never happened. Of course, China's space program has a more closed structure compared to its Western counterparts, so silence is not unusual. However, in recent years, CNSA had shown a tendency toward open communication, especially when it could highlight technological achievements. The landing of the Zhurong rover, Chang'e 5 bringing samples from the Moon, and even spacewalks at the Tiangong station were all quickly announced. Therefore, capturing an image of an interstellar object, Atlas, should have been an extremely prestigious opportunity for the agency. The fact that they did not highlight such an event suggests two possibilities. Either the data collected was not suitable for public release, or they were engaged in silent coordination with other agencies. The Indian Space Research Organisation, ISRO, released a brief, carefully worded statement on October 6th. It was mentioned that the data from Mangalyaaan's observation of Atlas was being reviewed, and the results would be shared after the analysis was completed. Such statements are typically used when dealing with ambiguous or controversial data. Saying analysis is pending means either the institution is not sure of what it has observed, or internal discussions are ongoing about how to present the data. Looking at ISRO's history, this stance is unusual. The agency typically announces its preliminary findings within a week. especially when the observations involve national pride. Therefore, the month-long silence is indicative of an extraordinary situation. Either the data was being examined very carefully, or the release was delayed due to external pressures. Considering this entire picture, a clear pattern of coordination emerges between NASA, ESA, the UAE, China, and India. Of course, this doesn't have to mean that everyone sat down at the same table and explicitly decided to hide the data. However, there could be implicit, mutually aware coordination. Each institution might have come to a similar conclusion based on its own interests. Publishing the data increases risks. Waiting is safer. When NASA was delayed, ESA might have seen it as a reasonable example. When China remained silent, the pressure on India to provide an explanation might have decreased. The UAE may have deleted its previous enthusiastic posts and returned to the official line. What resulted was not a clear conspiracy, but rather a coordinated blackout, the natural outcome of shared interests, uncertainties, and international balances. And perhaps that's exactly what the October 3 silence was. A moment when no party wanted to take responsibility alone, and instead they all shared it by remaining silent together. But there are also signs that the coordination might not only have been indirect but much more explicit. On October 10th, 2025, exactly 1 week after Atlas's close pass by Mars, representatives from NASA, ESA, and the Japan Aerospace Exploration Agency, JAXA, unexpectedly met during the International Astronautical Congress, IAC, in Milan. This meeting was not on the official schedule. It didn't appear on the participant list or in the session plan. However, a science journalist noticed that senior officials from the three agencies entered a conference room labelled Private Session together and reported it. According to the official statement, this meeting was a brief session on routine coordination between Mars exploration missions. However, both the timing and the level of participation make this explanation unconvincing. Just 7 days after the October 3 pass, the top executives of the three major agencies meeting behind closed doors overlaps with the controversy caused by Atlas. Such high-level and secret coordination on Mars operations has never been done before. This creates a strong impression that the meeting was aimed at consulting on the non-public October 3rd data. Adding to this is the issue of classification. In the US, data from space missions is typically made public. However, if a situation is deemed to concern national security, the data can be classified. This is extremely rare in planetary science missions because most things observed in space, rocks, ice, atmosphere, minerals, do not pose any military threat or strategic value. But if a spacecraft observes something indicative of advanced technology or an unknown structure, the situation changes. Such a finding would be viewed both as a potential threat and an opportunity. In this case, the October 3 data may have been removed from the normal scientific data flow within NASA and directed to intelligence agencies for review. For reasons of pre-assessment, the data could have been pulled from scientific databases and moved to a restricted access archive at the level of the National Security Council or the Department of Defense. This means that the data may have ended up in the hands of intelligence analysts rather than scientists. Similar security mechanisms exist within international institutions as well. Among ESA member countries, France, Germany and Italy each have intelligence units that evaluate space observations from a defense perspective. Although the UAE Space Agency is small, the country has strong intelligence ties with its Western allies. China's space program is directly controlled by the People's Liberation Army. Every piece of data undergoes military censorship before being published. India's ISRO is nominally a civilian institution, but observations of strategic importance are shared with the Defence Research and Development Organisation, DRDO. If the October 3 observations entered these institutions' radar as a national security issue, each country would have produced the same result within its system. The data becomes classified and is not made public. Thus, the simultaneous silence of these 5 seemingly independent agencies would, in fact, be due to a common cause. In other words, the October 3rd silence is not just a scientific hesitation. It could be a moment when the leading space institutions of the world simultaneously switch to security mode. And this elevates it from a simple delay to a historical blackout. Avi Loeb clearly stated that this approach is wrong both scientifically and humanely. In an article published on October 15th, he wrote, "If Atlas is an artificial object, a probe or a remnant from another civilization, this information should not remain locked in government vaults. It should be shared with all of humanity." According to Loeb, the discovery of extraterrestrial intelligence would be the most important finding in human history. It should be considered the shared heritage of our species, beyond national borders or security concerns. Concealing the truth would be both ethically wrong and practically unsustainable, as such a great secret would inevitably leak sooner or later. The right approach, according to Loeb, would be to share the information up front and decide together how humanity should handle this discovery, without leaving the narrative to uncontrolled leaks. However, governments do not think like scientists. Their priorities are not information, but control, stability, and strategic advantage. If the October 3 data truly revealed something extraordinary, the questions in the minds of officials would be very different. What will happen if we disclose this? Will the public panic? Will we lose control of the narrative? Could enemy countries use this information for their own advantage? Do we need to evaluate this information strategically first? These questions are not unreasonable from a governance perspective, but they are devastating from a scientific one, because the advancement of science requires openness, transparency, and collective verification. However, this approach replaces science with bureaucratic caution and curiosity with political calculation. Of course, a simpler explanation is also possible. A scenario with no secret agreements, intelligence pressure, or coordinated blackout. Perhaps the October 3rd data was truly ambiguous. The images may have shown a shape that could be interpreted as both natural and artificial. The spectral data may have yielded unusual but physically possible results. Thermal measurements may have been higher than expected, but they could be explained by the surface composition. In this case, the institutions may have chosen to act cautiously, fearing that sharing the data prematurely would create sensational headlines and incorrect conclusions, especially before certainty was achieved. Releasing uncertain data too early is risky both scientifically and socially. Conspiracy theories spread, misinformation takes root, and public trust is undermined. On the other hand, waiting, collecting more observations, conducting comparative analyses, and releasing the data when the picture is clearer is bureaucratically the safer option. So, the October 3rd silence points to one of two possibilities. Either something truly extraordinary was found, and the world was not ready for it, or there was no certainty at all, and no one wanted to take the risk of sharing uncertainty with the world. Indeed, 32 days is an unusually long period for data review. In the scientific world, even uncertain or controversial findings are typically shared within a few weeks as preliminary assessments. These early releases allow other researchers to analyze the data, make comparisons, and catch errors. Yet, more than a month has passed since the October 3rd observations, and still no clear statement has come from any institution. Such a long silence suggests that the data was not just uncertain, it either showed something significant, or the institutions are preparing for a larger coordinated announcement. From this perspective, December stands out as a critical turning point. If the institutions are indeed planning a joint announcement, they will likely want to align it with new observations that can verify the October 3rd data. This is because Atlas reached its closest point to the Sun, perihelion, on October 29th and remained behind the Sun, making it unobservable until the end of November. By mid-December, both ground-based telescopes and spacecraft like Juno or Parker Solar Probe will be in position to observe it again. These new observations will offer the opportunity to verify or disprove the October data. If Atlas is observed again in December and the data is consistent, the institutions can present it to the public with the explanation, "We waited to ensure accuracy before sharing." This would provide a message of transparency and justify the delay. A statement like, "We wanted to avoid hasty conclusions, coordinate the international response and proceed with accurate information," would likely be accepted by the public, especially if the findings are clearly shared. However, if December comes and goes with no announcement, the situation will change. If the silence extends into 2026, it will no longer be seen as scientific caution, but rather as a deliberate blackout. Even now, online communities are suggesting that evidence of Atlas's artificial origins was found on October 3rd, that governments have suppressed this information, and that even the US government shutdown was specifically timed to prevent the release of this data. Such theories rapidly sprout in the information void. As official statements are delayed, reasonable silence gradually turns into suspicious silence. Comments on the internet, forums, and documentary channels begin to create their own narratives in the absence of official information. The longer the silence persists, the less credible innocent explanations become, as people naturally assume that something is being concealed. Ultimately, December will not only be the period when Atlas emerges from behind the sun, it will also be the turning point where humanity will see who will control the narrative of this story, science or silence. We are at the point where everything converges. The capabilities of the 7 spacecraft, the timing of a government shutdown, and the silence of 5 space agencies all point to the same conclusion. The data collected on October 3rd captured much more than a typical scientific event. To understand this, we need to look at what the instruments could truly observe and what would be considered undeniable evidence. The cameras in Mars orbit could resolve Atlas's details, ranging from 2 to 5 kilometers from a distance of 45 million kilometers. This is insufficient for small details, but more than enough to see the overall shape. Natural objects are irregular and random in shape. However, artificial objects have symmetry, straight edges, and specific geometric order. If Atlas exhibited such a pattern, the images would have clearly revealed this. Normally, ambiguous images are shared because they encourage scientific debate. However, if nothing was published, it suggests that these images were clear enough to lead to a definite conclusion, not just a discussion. Moreover, spectroscopy provides even more conclusive results. Every material has a unique spectral signature. Natural objects contain substances like silicates, iron, nickel, and ice. If Atlas's spectrum did not match this pattern, it would prove that it was not a natural object. Artificial materials such as refined metals like aluminum, titanium, and steel create absorption lines at specific wavelengths with their high purity and crystalline structures. Alloys produced for thermal or durability properties give spectra that are incompatible with natural minerals. Composites like carbon fiber or ceramics used in spacecraft also leave signatures of industrial processes. If the October 3 spectroscopy detected such materials, it would present irrefutable evidence that Atlas was not a natural object. Every spacecraft in Mars orbit has observed Atlas and data has been collected. These data are available on the servers of NASA, ESA, CNSA, ISRO, and the UAE Space Agency, but have not been released yet. If the spectrum had been normal, the agencies would have announced it immediately. The silence suggests that something is not normal, and that something has been discovered about Atlas that would lead to a significant change in our understanding of what it is. Thermal imaging adds another layer. The temperature of an object is determined by the heat it receives from the sun and its internal heat production. If Atlas was 1.5 astronomical units away from Mars, a dark object would be around 200 Kelvin, while an icy object would be around 150 Kelvin. If an object's temperature deviates from these estimates, either its albedo is incorrect, or it is generating internal heat. Natural objects do not produce significant internal heat unless they are geologically active. Earth remains warm due to radioactive decay and residual heat from its formation. Jupiter's moon, Io, on the other hand, is volcanically active due to tidal heating caused by Jupiter's gravity. However, small objects like asteroids and comets are typically cold because they lack sufficient mass. If Atlas is cold in line with these predictions, it would indicate that it is a natural object. But if its temperature is much higher, this would suggest that it is an object generating internal heat. Machines produce heat. The UAE's HOPE probe was in an ideal position to measure Atlas's thermal signature on October 3rd. In an orbit unobstructed by Mars, its infrared spectrometer was sensitive enough to detect even a few degrees of temperature difference. If Atlas had been cold in line with the expected temperatures, HOPE would have measured it, and the UAE Space Agency would have announced it. This would have been simple data supporting that it was a natural object. However, no announcement was made, and the agencies even retracted their previous observations. This suggests that the thermal data revealed something unexpected. When agencies decide which data to release and which to withhold, we must remember that planetary science data is generally made available to the public. NASA, ESA, and other agencies have policies that mandate the release of obtained data within a short period of time. This transparency is crucial for ensuring scientific accuracy, preventing errors and fraud, enhancing scientific interests and strengthening public support. However, there are exceptions. Data related to national security can be kept classified, such as military satellite observations, reconnaissance imagery, and signal intelligence. Additionally, data that has not been fully calibrated or preliminary results that may risk misinterpretation can be temporarily withheld. High-resolution data may also be restricted for commercial reasons. However, none of these exceptions apply to Atlas, as it is neither a military target nor a commercial entity. The October 3rd data is now over a month old and has matured to the point where calibration excuses can no longer justify withholding it. What remains is a single explanation. These data lead to conclusions that the agencies are not ready to release. Either it is definitively proven that Atlas is artificial, or some other unexpected and controversial discovery has emerged. Avi Loeb suggests that if the October 3 data shows artificial structures or materials, agencies might consult with governments before making any announcements. This is not a conspiracy, but careful crisis management. When you are about to announce humanity's greatest discovery, evidence of extraterrestrial technology, governments need to be prepared and know how to respond to the reactions. It is undesirable for 7 different agencies to make conflicting statements and cause panic on the same day. The coordination process takes time. International discussions with countries that have different political systems and priorities can take weeks or months. NASA must work in sync with the White House, the Department of Defense and intelligence agencies. ESA must coordinate with its member countries, each with its own government and priorities. China's space program reports to the Central Military Commission. Decisions are slow and secretive. India's ISRO is coordinated with the Prime Minister's office. The UAE Space Agency is tied to the royal family. Reaching an agreement on a joint statement among these organisations is a complex and lengthy process. During this process, the data is kept on classified servers. Scientists are silenced with confidentiality agreements, and journalists investigate information they suspect is hidden but cannot prove. The public is either unaware of or has forgotten about the secrecy surrounding October 3rd. This situation appears stable to governments, which is why there is no rush. However, stability is fragile. Leaks happen, scientists speak out, and data is shared informally. The longer the blackout lasts, the higher the likelihood that someone will break the rules and leak the information. At that point, governments lose control of the narrative, and the worst-case scenario in terms of crisis management begins. This is why December is important. If the agencies plan to make an announcement, a logical timing would be December. Atlas will come out of its solar conjunction at the end of November, and ground telescopes will be able to observe it again in early December. If new observations confirm the October 3rd findings, the agencies can announce everything together and present a consistent story. They could say, "We observed something extraordinary on October 3rd, waited to confirm it, and are now sharing it transparently." This narrative could satisfy the public. The delay could be explained as scientific caution rather than secrecy, and it would allow the agencies to maintain control over the message. However, this only holds if the December observations confirm the October 3rd data. If they do not, an atlas appears normal in December. Explaining the silence from October 3rd becomes much harder. After all, why would they hide a false alarm? There is also a darker possibility. What if the October 3 data was so shocking that governments decided not to make any announcement? What if Atlas is not only technological, but is also observing or reacting to us? What if the spectroscopy revealed materials we cannot explain, or an unexpectedly large and complex structure producing excessive energy? If the findings were this profound, governments may have decided that the announcement would do more harm than good. Public panic, religious upheavals, economic instability, and intergovernmental conflicts could be risks. In such a scenario, maintaining secrecy might seem like the lesser evil. At least until a response strategy is developed, international agreements are reached, and society is prepared, secrecy could continue. No secret stays hidden forever. History is filled with examples of secret programs that eventually came to light. The Manhattan Project, the CIA's Cold War operations, and Snowden's NSA revelations are proof of this. If the October 3 data is truly being suppressed, it will inevitably leak out eventually. Someone will speak, someone will publish. At that point, government's credibility will take a massive hit, and repairing the broken trust will not be easy. If you followed this journey, from the capabilities of the spacecraft to the political timing and the meaning of coordinated silence, consider liking and subscribing for deeper analyses of the mysteries governments don't want us to examine. Share in the comments whether you think the October 3 blackout was a bureaucratic coincidence or a deliberate suppression, and what it means for humanity. 7 spacecraft are still in orbit, and the data they captured on October 3rd is still available. Sooner or later we will see it. Whether through an official announcement, an unauthorized leak, or new observations, the truth detected on October 3rd will come to light. The question is not, will we learn it, but when will we learn it? And will governments disclose it, or will they lose complete control over it? Sweet dreams.